Example 5. A recent survey found that 68.6% of the population own their homes. In a random sample of 150 heads of households, 92 responded that they owned their homes. At the 1% level of significance, does that suggest a difference from the national proportion?
In this example, go to analysis, go to comparison, choose single sample test, choose sample proportion. The sample statistics will be 92 divided by 150, which is 0.6133. Sample size 150. The population's parameter is 68.6%, which is 0.686, which is also the null hypothesis. Let's continue. This is the result that we get. In order to use the result, null hypothesis is the proportions equal to 0.686 against the alternative is not equal to 0.686. So here we will be looking at these statistics. You'll find that the p-value is 0.972. So therefore, we fail to reject case not, since the p-value is greater than the significance level.
Example 6. American Demographics, January 2002, reported the results of a survey on the planning habits of men and women. In response to the question, what is your preferred method of planning and keeping track of meetings, appointments, and deadlines? 56% of the men and 45% of the women answered, I keep them in my head. A nationally representative sample of 1,000 adults participated in the survey, therefore, assume that 500 were men and 500 were women. Is there enough evidence to conclude that the percentage of men who prefer keeping track of appointments in their head is larger than the corresponding percentage of women, at 1% significance level?
In this example, go to analysis, choose comparison, choose test of two proportions, choose values entered on this form, and also choose independent proportions. On the frequency, you have to put in the frequency value, so change the 56% into frequency. That will give you 280 out of 500, and for the 45%, that will give you 225 out of 500. Click in continue. That's the result that you get. And to use the result, your hypothesis is proportions of men and women is the same against the alternative, proportions of men greater than the proportions of women. The test statistics is this one over here, which is Z test statistics, value of 3.479. The p-value is 0.0002. Since this is a one-sided test, we divide this by 2, and since it is smaller than alpha, which is 0.01, we will reject the null hypothesis. Since p-value smaller than alpha.
Example 7. A survey at a ballpark shows this selection of snacks purchased. At 10% significance level, is the snack chosen independent of the gender of consumer?
In this example, we have to key in all the values into OPENSTAT this way. For the first variable is for the row, second variable is for the column, and the third variable is for the frequency. Then go to analysis, choose non-parametric, go to chi-square, choose use frequency in a variable, then put in the frequency value, add the variable to analyze, choose row variable and column variable, click on show observed frequencies, show expected frequencies, click on compute. That's the result that you will get. And to test the hypothesis, look for the chi-square. Here the chi-square value is 6.342. The p-value for the chi-square statistic is 0.042. Therefore, you can reject the null hypothesis at alpha is equal to 10%.